KVL equation of the given loop has to be written. So let us see first how many closed loops are there. 1 ohm, 3 ohms, 25 volt, 2 ohms. So there is only one closed loop. So we will get one equation for the given circuit. Let us assume I1 is a clockwise current which is flowing through this particular circuit. So we have to write down the equation into a clockwise direction only. Just let us quickly see what are the voltage drops that will be produced across the resistors. So this will be plus 1 I1 minus plus 3 I1 minus, this is minus plus, already the voltage across source is given to us 25 volt, and this is plus minus 2 I1. So we have to write down the equation that summation of all the potentials in a closed loop or a mesh to be equals to 0. But first, let us understand the convention, how we write down the uh, algebraic number for any voltage drop across the component. So let us quickly see that. Assume there is a resistor R1 and current I1 is flowing through the resistor like this. So the drop across the component will be given by I1 R1 as the polarity shown in the figure. Now let us assume that we are writing down the equation in this direction. So we can find we are moving from plus sign to minus sign. It means that there is a drop into the potential. So we will write it down as minus I1 into R1. So drop across this is given as minus I1 into R1. Second condition, resistor R2 is a resistor inside the circuit and I2 is the current that is flowing through the resistor. So how the drop will be? Plus I2 into R2 and minus. And let us say you are traveling into this direction and you are writing down KVL equation into this direction. Now, since you are moving like this, you can observe that you are moving from plus to minus. It means that there is a gain in potential. So how you are going to write down the algebraic drop across this component? Plus I2 into R2. So remember one thing, when you are moving from plus to minus, you will write down minus sign, and when you are moving from minus to plus, you will write down plus sign. This is as far as resistors are concerned. Let us see about the voltage drops now. V1 is a voltage source connected with the polarity shown in figure. If you are moving in this direction, then you are moving from minus sign to plus sign. It means that there is a gain in potential. So this will be represented as plus V1. In case number 2, V2 is a voltage source connected in your path and you are moving in this direction. So you can find you are moving from plus sign to minus sign and the drop will be given as minus of V2. So one thing is very clear, whenever you are moving from lower potential to higher potential, you will write down plus sign, and whenever you are moving from higher potential to lower potential, you will write down minus sign. So this is a law of writing down the KVL equation. Now let us go into our original circuit and solve the problem. Starting from this point, this will become minus 1 into I1. Why minus 1 into I1? You can see carefully over here, you are moving from plus sign to minus sign. So there is a drop in potential. So this will become minus 1 into I1. When you move like this will become minus 3 into I1. Why minus 3 into I1? Once again the same story. You can observe you are moving from plus sign to minus sign. So minus 3 into I1. We can see we are moving from minus to plus, and that is the reason this will become plus 25. Next, we are moving from plus to minus, and this will become minus 2 into I1. So let us write down the equation again. First point, minus 1 into I1 minus 1 into I1. Second element, minus 3 into I1. Third element, plus 25. Fourth element, minus 2 into I1 is equal to 0. So now you can rearrange the equation. Minus 6I1 is equal to minus 25. So I1 is equal to 25 by 6 amperes. The direction of current will become clockwise, the same direction that you have assumed. Now let us see what will happen if I increase one more loop in the given circuit. In this, how many mesh are available? 1 ohm, 3 ohm, 25 volt, 2 ohms. This becomes mesh 1, and we can show a clockwise current I1 flowing through this circuit. Second mesh, 19, 1 ohm, 3 ohms. Once again, back to the same point. So this will form a second mesh, and we can show clockwise current I2 inside this mesh. Let us show the currents. So I1 is a clockwise current flowing in mesh 1, and I2 is a clockwise current flowing in mesh 2. Now here is one doubt that always student ask. Sir, looking towards the polarity of 19-volt battery, why you have shown the I2 current in clockwise direction? So you don't need to worry about it. I2 is the assumed direction of current. If the assumed direction of current is not as that of the actual direction of current, you may get this answer as a minus. So our final answers will tell us that whether our assumed directions of current are correct or not. So you don't need to look towards what are the polarity of the voltages while assuming the directions of current. So that is a doubt which is always asked by students. Once we decide that currents will be clockwise, you assume that currents are clockwise. Let us start writing down the equation for loop number 1. For this, minus 1 into I1. But when you come to this particular point, this 3 ohm component has two currents, I1 and I2. So now how to write down the equation? For that you need to see which current is flowing along with your direction of travel. So our direction of travel is like this and I1 is flowing in our direction of travel. How I2 is flowing? I2 is flowing like this. Both of them appears to be clockwise, but if you see with respect to 3 ohm component, then I1 is flowing from up to down and I2 is flowing from down to up. The equation for this branch will be minus 3 bracket open I1 minus I2. Why I1 minus I2? Because I1 is the current that is in the same direction of travel and I2 is the current that is in opposite direction of travel. Third component plus 25 ohms. Fourth minus 2 into I1 is equal to 0. Let us write down the equation now. First component minus 1 into I1. Second component minus 3 I1 minus I2. I hope you are clear about why I am saying I1 minus I2. Minus 3 I1 minus I2. Third component plus 25. Why plus 25? Because we are moving from minus to plus. Plus 25. Next component minus 2 into I1 is equal to 0. So mesh 1 equation has been completed. If you solve this, open this bracket and write down the equation in proper fashion, then it will become minus 6 I1 plus 3 I2 equals to minus 25. This will become your first equation in two simultaneous equations. Equation for loop number 2, very clear. First component minus 19. You are moving from positive to negative, minus 19. Second component minus 1 into I2. There is no component in this particular line, so there will be nothing for this. Now next is very important. When you move like this will become minus 3 I2 minus I1. Now why I2 minus I1? Because I2 is flowing like this and I1 is flowing like this. So now I2 is in direction of travel. I2 is in same direction of your travel. So this will become minus 3 I2 minus I1. Minus 3 I2 minus I1 is equal to 0. Let us write down this equation in proper fashion. Plus 3I1 minus 4I2 is equal to plus 19. This will become your equation number 2. And now if you solve these equations simultaneously, you are going to get values of I1 and I2. Let us see now if three mesh are there, how to handle the problem. Going quickly, this is your first mesh. Current for this mesh will be represented as clockwise current I1. This is your second mesh. Current through this will be represented as clockwise current I2, and this is your third mesh. Current through this will be represented as clockwise current I3. Let us show the clockwise currents now. Current I1, current I2, starting with loop number 1, the first equation, minus 1 I1 minus I3. Second parameter, minus 3 I1 minus I2. Third parameter, plus 25. Fourth parameter, minus 2 I1 is equal to 0. Now if you open the brackets and write down the equation systematically, you are going to get minus 6 I1 plus 3 I2 plus 1 I3 equals to minus 25. This is your equation number 1. Starting with second mesh, minus 19, minus 1 I2 minus 1 I2, no component over here, minus 3 I2 minus I1 is equal to 0. Rearrange the equation. Plus 3 I1 minus 4 I2 is equal to plus 19. This is equation number 2. Third mesh equation, minus 2 minus 6 I3 no component over here, plus 19 minus 1 I3 minus I1 no component over here, so equals to 0. Rearrange it. Plus 1 I1 minus 7 I3 equals to minus 17. This is your equation number 3. And if you solve this equation simultaneously, you are going to get your answer. So thus we have seen how to solve a problem when you have single loop mesh, when you have two loop mesh, and when you have three loop mesh.